Well, students, in the last class, we have derived two forms of the generalized Wiener process that governs the price process of a risky asset like stocks, right? In this lecture, we will try to develop a method, basically a numerical method, to simulate this stock price process based on one of these two equations. For instance, we will take the second one, that is ds is equal to mu tilde s dt plus sigma s dw, and try to develop a numerical method which comes under a class of methods called Monte Carlo methods. Of course, since it is a numerical method, the first step that we have to do is to discretize the interval 0 to capital T into n subintervals with the node points as T0, T1 up to Tn, where T0 is 0, T1, T2, and so on, Tk, Tk plus 1, and so on, till Tn minus 1 and Tn, which is basically equal to capital T in such a way that Tk plus 1 can be written as Tk plus a positive number, which is sufficiently small, denoted by delta T, that can be obtained by this expression, capital T divided by the n that we have chosen, right? So this is a standard step that we will always do in any approximation procedure that we will be doing. And with this discretized grid points, we will now try to set up a numerical method, which we will call as Monte Carlo simulation. The idea is basically to replace the operator ds by the approximation delta s, and that is equal to mu tilde s k. So this is delta s at k into delta tk plus sigma sk delta wk. What is delta s? This is nothing but sk plus 1, which is the value of the stock process s at the point tk plus 1, which is actually the approximated value, not the exact value, minus sk. So that is what we denote by delta sk. Again, sk is nothing but the approximate value of the stock price s at the point tk. That is equal to, of course, we know what is this. This is nothing but mu sk, and we will not put delta tk because we are basically working with uniformly discretized grid points. Therefore, all delta tks are equal to delta t. Therefore, you don't need to put this. This is nothing but tk plus 1 minus tk plus sigma sk into wk plus 1 minus wk, right? If you recall, the way we have defined this w, which is the Wiener process, we defined it as a random walk, and that is given by wk plus 1 minus wk is nothing but epsilon tk into root delta t, right? So you will replace this here, and this is just delta t, and thereby we get sk plus 1 is equal to sk, and sk is sitting in all the terms. Therefore, you can take it out and write it as 1 plus mu delta t, that is the second term, plus sigma sk came out, therefore it's as it is, and instead of delta wk, I will put this epsilon tk into root delta T. So that is the accumulation factor for the price that you paid for the stock at the time Tk. Okay, and that gives you Tk plus 1. If this is not there, then what you have is the classical compounding formula, per period compounding formula, with the interest rate being fixed as mu, right? And because of this term, you have the randomness coming into picture through this normal distribution. Remember, this is nothing but the standard normal random variable with mean 0 and variance 1. Okay, so this is how we have defined it. Recall, it is coming from our basic assumption that it looks like a Gaussian white noise, right? Therefore, our simulation formula finally takes this form. Okay, remember, I have used basically this equation to get this formula. Similarly, you can also start with this equation and get a Monte Carlo equation. Okay, so I leave it to you to derive this, but that formula will actually give you log of S. Therefore, if you want to get the stock price out of that method, then you have to take the exponential to get the stock price, because that basically gives you log of the stock price, whereas this one directly gives you stock price. So I have chosen the easier one to illustrate the method. So finally, the formula looks like this. Let us take an example. We are given the parameters mu tilde as 0.1 and sigma as 0.4. So we are straight away given this as 0.1 and this as 0.4. Well, how will we get this in the practical problems? That is not very standard. Different people use their own way of estimating. For instance, experts may use different parameters and different aspects. For instance, one basic parameter that everybody will use is their own prevailing interest rate, right? They also try to understand the fundamental capacity of the company in terms of their business model, so that they can get what is the revenue that they can get and what is the final profit that they can make out of the money that you are investing into those stocks. All that they will do, which is called fundamental analysis. They will also listen to the management commentaries on the earnings going forward and many other events like geophysical situations and general market conditions. Based on many such situations and parameters, people generally estimate these values. Okay, even from a very simple point of view, there are many statistical estimators to find these parameters based on the past price data. That may sound a bit contradicting because all these models are developed basically on the efficient market hypothesis. Therefore, using past price data to estimate these parameters may look contradicting, but practically, you just want some estimated values of these parameters. Therefore, there's no one single method that can be used to do this. There are many ways, many methods people use, and therefore, even among people who use this kind of simulators, even then, their final price predictions will be different because their basic parameters may be obtained from their own methods. Therefore, you just cannot conclude that one particular simulator will perfectly work for any market conditions. These are just some basic methods that we introduce from an academic point of view. Assume that the stock is trading at 1887.75 on 31st December 2021. So basically what we have is S0, therefore S1 can be obtained using the Monte Carlo simulation equation that we proposed in the previous slide, and that is given by 1 plus mu tilde is given by 0.1 into delta t plus sigma, which is 0.4 into epsilon of t naught. What is this? This is nothing but random number. So how you get this random number? Well, you have to keep in mind that this is normally distributed random number with mean 0 and variance 1. As I told you, if you are using some standard softwares like MATLAB or R or anything, there are commands to generate these random numbers. So you can use any of those commands to generate this random number. Then you have root delta t times S naught. S naught is this. That will give you S1. Okay. Now, what is this delta t? Well, that depends on in what time scale we are going to simulate this price process. For instance, let us take in this example, we are interested in predicting the stock for next 8 weeks on a daily basis. So in the calendar of 2022, these 8 weeks will range from 2nd Jan 2022 to 27th Feb 2022. Okay, and that we are going to do on daily basis. But look at these parameters, they are given per annum, right? Therefore, you have to multiply these things to get these parameters per day. Okay, so that gives you a clue of how to get this delta t. Now assume that there are 52 weeks in a year, and assume that there are 5 working days per week. Of course, there may be some holidays in between, but just for the calculation purpose, to apply this formula in a rather simple manner, let us assume that all the weeks, all these 8 weeks have exactly 5 working days, ignoring all the holidays in between. You can see that delta t can be taken as 1 by, there are 52 weeks and each week has 5 days. Therefore, 52 into 5, 260 days are there in such a year. And since we are going to simulate for every day, therefore, it is appropriate to take delta t as 1 by 260. From the examination point of view, I will give all the relevant information about how you have to get this delta t. It is only thing is you have to collect all this information and put it in a right form to get this delta t. That is the only simple exercise that you have to do. Otherwise, you know how to get this delta t. So that gives you S1. Once you get S1, you can simply put that value in the place of S0, and you can get S2 as again 1 plus 0.1 into delta t, which we have already calculated in this particular example, plus 0.4 into, now again you will generate another random number. That random number is not necessarily equal to this one. Okay, so for every time step, you will generate one more random number, and that random number, which we will denote by epsilon t1, but in your code, it will be generated by the computer into root delta t times S1. So whatever you computed here, that you will plug. Similarly, S3, exactly the same. Only thing is this epsilon t2. It's another random number that you will be plugging in here. S2, like that, you will keep on going. Okay. I have just done the simulation on my computer where I have taken the stock price from 1st Jan 2021 to 31st December 2021. So this I have taken from the market, and this graph is plotted with the daily closing price of the Infosys stock during this period. Now I'm going to simulate this stock price using the Monte Carlo simulation. Remember, I'm not trying to predict. Okay, I'm just simulating. Every time you run the code, you get different price path. That is because your computer is generating different set of random numbers every time you run that code, right? Therefore, every time you run the code, you will see a different price path simulated by the Monte Carlo simulation equation. I have run this code for 3 times and got 3 different price paths for the period 2nd Jan to 27th Feb. Again, I'm telling this is not to predict the stock. It is just to simulate the stock price path. That's all. In no way we are predicting. In fact, throughout this course, we will never teach any method to predict the price of a stock or option or anything. It is just some basic fundamental methods that can be used to analyze or simulate these price paths. That's all. How you will use it in your life is something which we will never attempt to answer. Okay, so this is a very interesting simulation method called Monte Carlo method.